Okay, so we have a sequence that can play back, and we know we can click on each of these. So let's bring all those pieces together to make it so we can try to solve the sequence puzzle. All right. Um, I think one of the things I'm going to need here is a way to initialize my sequence and extend my sequence. So I'm going to make a private utility method called extend sequence, which adds one to the sequence. And here I can use some of the built-in features here to stub out the definition. Good. And so what this can do is say, all right, what am I going to add? It's fmath rand range, an integer from 0 to number of options minus 1, so from 0 to 3. And then we can say sequence add that element. All right, so previously oh, I apologize, I erased it earlier. We had a for loop in here that was populating the sequence, but now all I want to do is extend the sequence. Oops. So when we first create it, this makes sure we have a single element that's randomly generated within my sequence. Good. All right, so when I press the button, I want that to route a guess over to the sequence puzzle. So to make that work, I'm going to add a public method here called guess. Let's call it the guess. So I want my button to be able to call this public method and tell it what its guess is, because you know the way the sequence puzzle works is that if the guess is correct, we will simply extend the sequence, and if the guess is incorrect, we reset and play a new sequence. So I need my buttons to be able to call this method. So that means my buttons need to know who their puzzle is. But that's easy enough to do. That may as well be private. My sequence puzzle button will have a reference back to its sequence puzzle. And this is a fairly common sort of structure if you have complex objects network and your children need to know who their parents are. We saw this earlier in the tutorial where this header file doesn't actually have to know anything about the details of a sequence puzzle. It just needs to know that it exists. So I can use this trick to just say, it's essentially like an inline forward declaration saying, yeah, there's such a thing as a sequence puzzle, but it doesn't really matter at this point. Where it does matter is in sequence puzzle button. But one other piece that I need here is that my puzzle button now needs to know what its index is, so that it can tell which guess it's making. So back over here, nope, not there. Let's see, in sequence puzzle, when we create the button, we can say button index, oops, is going to be I, and we can say buttons puzzle is this. Good, so now button should be able to communicate back with the puzzle. But I need to do that on these click events, right? Actually, I'll do it when the mouse is released. So that means this needs to be, both of these actually then need to be protected so my subclass can see them, and they do need to be U properties. Right, so they're going to be specified in C++, but they need to be readable from blueprints. All right, so let's see if we can make that work. Oh, let's take a look at what went wrong. Oh, here we are. Index. Oh, yeah, if these are protected, then of course I can't see them to initialize them. So they have to be like color, public, and blueprint read only. Of course. Try again. And while that's going, we can go bring up puzzle button. and we can look at its onReleased. So again, if you play a game like Simon, it's not the pressing of the button that does the test, it's actually the releasing of the button. So here we should be able then to say get the puzzle and call guess. Uh-oh, maybe not. Let's check. Yep, has to be exposed. And this will be a blueprint callable. Great. Let's get that started. So here's a case where we have a method that is callable through blueprints, but the implementation is still going to be here in C++ because that's where I have all the information that I need. Let's see. Oh, of course the problem is I don't have an implementation for that method, right? So it can't compile because I'm saying, hey, this method exists, but I haven't written it. So let's do something about that. Okay, good. Of course, we need this implementation for the method called guess. Let's see, is there an easy way to do this to get started? We're going to have to keep track of our index, but in terms of just getting the plumbing working, let's see how we can just do a simple log message. Right, so this is like the equivalent of print string in blueprints, right? When you just need to log some information, you can use UE log, and that should be enough now that it'll compile. Okay, good. So back over here, when the button is released, we have the puzzle. We should be able to call guess. And what is our guess? Well, our guess is the index of this button. And so when we call guess, what we should see now is a log message. So let's see. There's our puzzle. We'll guess right. Look over at, oops. I have to be able to view the output log. Here it is, output log. And let's look for our message here. This is a sample log message. Good. So that means all of our plumbing is working. So now we can go in and see if we can't make that work in C++ here. All right, so what do we actually want to do when there's a guess? We're going to need to keep track of where we are in the sequence. So let's make a field here. Let's call it sequence index. That'll be our current place in the sequence. So that'll start at 0, which is the default value. That should be fine. And now we want to say the actual next guess, the correct answer, is going to be the sequence index out of sequence. Notice that we can use the bracket subscript notation from C++ on a T array because C++ has operator overloading. So this will transform into however a T array's implementation wants it to look, but that's convenient for writing code. All right, so if our guess is equal to the actual, right, so if we guessed correctly, let's just throw in a quick log here too. We can say correct guess. And if you wanted to, you can format some text here. So we could do something like that, right, just to see what the actual guess was. And that should then print it to the output area. All right, so if I guessed correctly, I want to increment my sequence index. And now I need to know, am I at the end of the known sequence? So we can say if sequence index is sequence.num. I really don't like the name of that method. I want it to be length or size, but it's num, so we got to deal with it. So this means we need to extend. So we can say we have to go back to 0 for the sequence index. We have to extend the sequence by 1, and we'll play the sequence. Remember, we have that play sequence method already defined, even though it's implemented in blueprints. Alright, so this is the case where our guess is correct. Oh, I don't think there's anything special to do there. If our guess is correct and we're not at the end, then we simply increment the sequence index and we're fine. This is the case where our guess was wrong. Let's get the C++ conventions there. Alright, again, we'll just throw in a quick log message. And what we need to do is, again, reset the sequence index. And now we need to actually reset the sequence itself. So that looks like sequence.empty. And this is not a Boolean. It's not asking if it's empty. It's telling it to empty itself. And then we extend the sequence, right? That'll give us our first element with sequence index back at 0, and play the sequence because we're starting a new puzzle. Well, I sure hope that's right. Of course, I have the advantage that I wrote this offline first, right? So I do have a couple of notes. Let's see if this works okay. Seems Unreal Engine just got a little confused when I shut it down and reopened it and recompiled. Here's what we got. Not too bad. Alright, let's try getting it wrong. Get a brand new puzzle. It looks like we should probably add a little bit of delay after when I release the button and before it calls play sequence. That's easy enough to do. Also, there's a state problem where I can go in and start guessing while it's in the middle of playing a sequence, and that's going to cause all kinds of problems. So really, I should put in some kind of a state machine. Obviously, we should add some sound effects. If I wanted to track how many in a row I got right, it would be easy enough to add that into the C++ and then expose those fields and bind them into some UMG elements, right? Make a nice user interface out of this. But for the sake of this tutorial, I think that's pretty good. I hope you enjoyed it. I hope you can take some of these ideas and go off and make some great games. Thanks for watching.